Hey, what's up? I'm Joachim, and welcome back to this addendum of Houdini for C4D artists. Today we'll be learning about Houdini's new scene assembly concept, Solaris. And the purpose of this video is to get like a broad overview so that you know the basics of what it is, how it works, and why you might want to use it or not. My hope is that after having watched this video, you'll have just enough information to feel comfortable enough to get from scene to final pixel. And then together we'll go over the basics of scene structure and geo import, how to add cameras and lights, and how to render and shade using Karma and MaterialX. Now, before we jump in, I just want to preface this by saying that I'm still pretty new to Solaris and I'm learning these concepts myself. So if I get something wrong or if I miss something that you think would be of value to others, please feel free to leave a comment in the comment section and help us all out. Now with that out of the way, let's get right into it. So here's where we left off last time when we lit and rendered our setup using Redshift in the OBJ context or the object context. The object context used to be the only place for building out your scene and adding lights and cameras, etc. And then you'd have dedicated material networks where you'd build your shaders, as well as the ROP context where you'd tweak your render settings and so on and so forth. Now, in Solaris, all of these tasks are done in the same place, the stage context. But first off, what is Solaris? Solaris is Houdini's implementation of Pixar's Universal Scene Description, commonly referred to as USD. It's essentially a framework that is designed to be software agnostic, allowing artists to collaborate in a unified working space in 3D. Just like how ACES is designed to create a unified working space for color, USD does this but for 3D. So in theory, an artist could be doing layout and look dev in Cinema 4D, while someone else is animating a character in, say, Maya, and a third artist might be working on a simulation in Houdini, for example. Previously, merging those elements together in one scene would be a nightmare of broken exports, alembics, FBXs, ars proxies, just to mention a few. You probably know what I'm talking about. With USD, those elements could be brought together into one stage as individual USD files. And since all the elements then are in a unified working space, you'd be able to render it with any engine of your choice as long as the renderer have USD support. So to see how this works in Houdini, let's hop into the stage context and bring in our setup. First, I'm just going to change this from my custom desktop to Solaris, and then we can get into the stage context by just clicking here and going to stage. Here in Solaris, the nodes or operators we work with are referred to as LOPs, or lighting operators. When we built our original setup, we did this at the geometry level using SOPs. You can think of the geometry level as being the factory where we build our parts, and Solaris as the stage where we assemble and shoot the final scene. There's three ways you can work with SOPs in Solaris. You can import using the scene import, and this will import multiple containers. You can pick some presets here. You can import only the cameras, lights, materials, or everything. There's also the SOP import, and this imports a single geometry stream. There's also a SOP create node that essentially just creates an empty geometry container inside of the stage context. For our purposes, we're going to use the SOP import. So what I'm going to do is I'm going to go here to the SOP path, and then I'm just going to pick our output path here. And then we can see that our main setup imports, and it is moving forward, but it's pretty slow. And that is because by default, it'll import everything as native instances. But we can change the definition if we go to primitive definition and then click this checkbox here. We can change this from create native instances to point instancer. And now it'll behave a little bit more like the copy the points would do in SOPs, for example. So now if I scrub, you can see that it's way faster. So in order to keep our stage organized, I'll want to start building out the structure of our scene. We can find the scene graph here to the left, and this is similar to how a file browser would display folders and gives us a clear overview of everything that is in our current scene. So I'm going to drop down a primitive LOP. You can see here that we now have a new primitive called primitive1, and that's just because by default, it'll just take the name of this node here. For this example, I'm just going to change this to be, well, I could actually just name the node here. So I'm just going to call it shot, but just to be explicit, I'll just rename it here as well. So now we have a shot directory. Now, before we move on, we're using a primitive LOP to set a directory. And confusingly enough, in Solaris, a primitive can be literally anything. It can be a camera, a light, a piece of geometry, a material, or a directory like we've created here. All of it are in USD referred to as a prim. And as a mental model, you can just think of a prim as being an item, if that makes it easier. If we take a look at the parameters of the primitive LOP and go down to primitive type, we can see that the primitive type is currently set to xform. You can think of the xform as being the equivalent to a null in C4D's object manager. And just like a null, it comes with a transfer parameter and a handle. For organizing directories, we can also use a different type of primitive called scope. And you can find that if you scroll down here to the scope, you can see that the icon changed. And you can think of the scope as being a pure folder. So unlike a null, it has no coordinates, so it's impossible to grab and move in the viewport. And this could be a lifesaver if you've ever accidentally nudged a parent null in C4D, for example, and ruined your entire layout. So because it lacks transform data, Solaris doesn't have to calculate any math for it when it's loading the file. And I mean, in what we're gonna build today, it probably won't make a difference. But if you imagine a massive scene with thousands of directories, using scopes instead of transforms can make the stage significantly faster to compute and lighter on your drive as well if you save it out. But for our purposes, I'm going to reset this parameter to xform, and then I'm also going to add another subdirectory called geometry. If we want to add multiple directories, we can just copy this line over and rename it to fx, for example, and you can see that the scene graph tree updates as we do that as well. And then I'm going to change the primitive kind, and I'm going to set this to group. But if I click this again, you can see that there's multiple options here. And I like to think of kinds as different roles or job titles that a certain primitive will have. By default, the kind is set to none. You can leave it like that if you don't know beforehand what role this primitive should have. Assembly is a top-level role, representing a massive collection, think of like an entire city. And a group is a collection within that. So in the analogy of a city, this would be like the city block with buildings and street elements. And a component is usually like a single complete prop. So that would be, for example, a building. And then finally have subcomponent, which is a specific part of that prop, like a window, for example. So I'm going to pick group. And to summarize, so primitive type just tells Houdini what this thing is. Is it a camera? Is it a mesh? Is it a folder? And primitive kind tells Houdini how it functions in the bigger picture of a scene. Let's move on and bring in our geometry to this new structure that we've created. We could stack it in line with our main branch, but this means that we'd manually need to adjust the import path for every SOP import that we might create. This is fine in our case, but it gets annoying really fast if you have different SOP containers you want to bring in. I also find that it gets a bit visually cluttered in your node structure. So here's what I'd like to do is that I'm just going to delete the second one, and then I'm just going to reset this to its default value. So another way we can add the SOP import into our directory is by using a graft branches LOP. I'll connect the mainstream to the left input and the SOP import to the right input. Then I'll just need to adjust the primitive path to shot geometry on this single node. I'll also set the source prim path to / so that everything from the second input gets grafted into the scene graph. Without it, the geometry won't actually appear in our hierarchy. I also want to import the background grid, so I can just copy this over, and then we can pick a new path. And the path we want to pick is the renderer BG, out BG, and then we can merge these together. Let's also rename this so it's a bit more clear what they are. So we can see here that because we've built it in this way with the graph branches, it takes both of these inputs and pipes them into the right place. Lastly, I'm just going to go to my background and just uncheck this create point instancer. All right, so let's create some materials. We can create material by dropping down a material library. Now I'll add this in line with the current geometry stream and hop in. We'll set this up to be rendered in Karma XPU, which is Houdini's GPU accelerated render engine. So here inside, we're going to create a USD MaterialX builder, and this workflow will be similar to how we built shaders with Redshift in the last video. You could also work with the RS USD material builder. So this is essentially Redshift for Solaris. So this is how you'd build shaders with Redshift in Solaris. But for now, we're going to use MaterialX. I'll hop in, and here I'm going to delete the displacement because I won't need it. So first, let's import the color attribute. We can import attributes to MaterialX with either the primvar reader or the geoproperties node, but I'll use the primvar reader for now. And by the way, in USD, Houdini attributes are referred to as primvars, or primitive variables. And then I'm going to pipe this into the base color, as well as the subsurface color and the subsurface radius. In the last video, we imported the CD attribute for Redshift, but in Solaris, this attribute gets automatically converted to a primvar called display color. If we head over to our scene graph and select the SOP import, we can see that we have a primvar called display color. I'll enter this variable name, and then I'm going to hop back up to my stage context, and now we need to assign this material. I'll click the autofill materials button, and this will make sure that we import any materials from our library into the scene graph tree. And then we can assign it in a couple of different ways. We can either assign the geometry here, so we could take the main branch and just drag it in here, and now it's assigned. And then we can start the render by just going up to perspective and switching from Houdini Vulkan to Karma XPU. And it's black because I forgot to change the signature from float to vector 3. And that's because this is a color, so it has 3 components, RGB. And we can see it in the viewport. So that's one way we can assign materials to geometry. If I disable the assignment, we can still see that the colors come through when rendering. And that's because the display color primvar automatically gets picked up by Karma, even though we haven't assigned the actual material. Here's another way we can assign materials. We can grab the material in the scene graph and simply just drop it on the geometry we want to assign it to. This will create a assign material LOP that does the assignment instead. And this can be useful if you want to override material assignments. But if we're checking the scene graph tree, you can see that the materials gets placed inside our geometry container. This is fine, but there might be instances where you'll want to export either the geometry or the material separately. So what we can do instead is we can move these materials to a separate branch and then graft them into our main branch. I'll separate the material library from the geostream. And with the graph branches LOP selected, I'll change the primitive path to shot only. So now we have the materials next to the geometry container. And then I'll show you a third way of assigning materials using the material linker. So here I'm just going to find my geometry, which is main, and then I can just drag the material to main. And that applies that link as well. So that's 3 different ways of assigning materials. I tend to use the material linker since it's visual, keeps the workflow clean, and makes assignments easy to track. The same goes for the graph branches LOP. It's a clear and precise way to point a branch to a specific place in the scene graph tree. Let's create a camera. And there's multiple ways of creating cameras. You can either just tab and search for a camera, drop it down, bada boom. You can also set your view in the viewport like this. And then you can just come up to the LOP shelf tool here and just hit Control and press left click. And that will create a camera to this view. So that's another way. You can also import cameras with this scene import. If you have cameras on the OBJ level, you can add this in. And this will just automatically fetch those previous cameras from the OBJ level that we had. And if we want to, I'm going to delete the initial camera, and then I'm going to go into here and look through my main camera. And then one thing we can do is we can just come up to our LOP shelf here and then just hold Control, left click. And now we've created a new native USD camera with that same transform. So that's a little hack. You could also edit the imported cameras if you drop down a camera edit LOP. And if we pick this camera, we could just, let's say we want to override the focus distance. So we can just work with whatever is the SOPs and just override the settings, but I just wanted to have a clean start, so that's why I did it this way. But the beauty and main point of this is that you can always edit and change parameters further down the line. And now we're doing it live in our session, but this applies even if you load in or reference in other files from disk. All right, so let's create some lights. I'm going to copy these graph branches once again, and I'm going to cut this connection here, and then we can create a light with the dome light. And this is just like in Redshift. You can load HDRIs in this texture parameter here. So I'm going to go to my doll hip text and use this HDR. And if I highlight the graph branches LOP, you can see that the viewport updates and we get some nice lighting. I'm just going to bypass this background for a minute. And then I'm going to uncheck this lock here from my camera, and then I can just zoom out. See how like fast and responsive this is compared to, I mean, Redshift, I guess. And this place as well, I think, yeah. I mean, it's not the fastest in the world right now because we are referencing SOPs live, but still, I think it's pretty snappy. Another quick tip is that if you click this camera button here, you can actually double click and it will zoom into this point. So this is a very fast way to like create multiple cameras. So you can create a new camera from this view, and then you can just like find cool angles and build up a camera library. So we can create another light. So I'm going to merge this, and then I'm going to create a area light, merge it with the dome light, and then let's set this up in a similar way to what we did last time. I'm just going to go back to the OBJ context and steal the transform that we did last time. I'll copy the parameters, and then we'll head back to the stage context and apply them. And then I'll do the same for the rotation. Something like that. Another cool feature of working with Solaris is the way you can target and control lights directly in the viewport. So if I bypass or mute these lights, now we'll have like the default Solaris lighting, but I can drop down a new light. I'll drop down an area light. Just pipe this in here. If you select the gizmo button, it will bring up some parameters for how you can control your lights. And if you change it from edit to specular, you can literally just click on your geometry. And if you want a specular hit here, you'll just click that. And then with the control and left click, you can control how far away this light should be. So let's say I want to have a specular hit here. There you go. Or here. You can also change this to diffuse, and then it will just move it a little bit differently, I think. But I think these modes are pretty cool, especially for like lighting products and stuff, because you can really like pinpoint where you want your specular hits to be at. And it's all in the viewport. So you also have some different option here. I won't go through everything, but it's very easy to sort of dial in the brightness. Maybe this is like too bright, so you can hit Control Shift, left click, and then we can turn down the intensity a bit. So lots of options here, and this makes lighting super fast and super fun, honestly. Now you might be wondering how we're able to render stuff even though we haven't set our render settings yet. And the reason for that is that Karma automatically has some render settings applied in the actual viewport. And you can access these if you hover over the viewport and press D, and this will bring up the display options. And if you go to render, here you can see the render settings for the viewport. You can enable or disable depth of field. If you want GI, this would happen in the diffuse limit, so you can up that if you want. So now we'll get some bounces. A lot of different options here. I'm not going to go into all of it, but just so you know that they exist there. So by default, when you start render stuff, it might look something like this, especially if you have an HDRI. So you'll see the background of the HDRI. So if you want to turn this off, hit D as I mentioned, and then you can go to background and then untoggle display environment lights as background. You'll probably see something like this, and that's because the color scheme is by default set to light, but I like to keep it to dark. I also don't like to see the grid and all of these like guides. So we can toggle them off here. We can toggle off the grid here and light here. So now we have something that looks a little bit more like what we'd be used to from Redshift, for example. So I'm going to go back and I'm going to re-enable my background. And right now you can see that the background is right in the center. And what I want to do is I want to mimic something that's similar to what we did in the OBJ context, where we just parented the background to the camera and then we just pushed it back in Z-space. Here's how to do that. Let's head back into the stage context. After the camera, we can create a parent constraint LOP. And here I need to specify the source, so the object that we want to have constrained. And this is going to be the background. So if I go back here, I can just cut this out and then I can drag the background into the source like so. And then we need to set a target, and the target will be the camera. We can just paste in this expression here again. This expression essentially says, give me the first node from the first input of the current node. So in our case, it'll return the camera, since that's the node that's piped into the first input of the parent constraint node. But we could also just drag in the camera here explicitly, and that works as well. So now you can see that the grid has been parented to the same orientation and position as the camera. And then we can just add another transform edit, and we can just push this back by a unit of 5. So now if I drag in the camera, you can see that we have sort of a similar kind of result. Let's also add a second material for our background. I'm going to copy our main material and I'm going to rename it BG for background. Here I'll delete everything except for the outputs, and then I'll want to append a surface unlit material. So this is like an emissive material, and then I'm going to create a color ramp as well. Then I'm going to go back to OBJ and just steal that gradient that we created last time. Paste that in there, pipe it into the emission color, go back, then I'll need to hit this autofill materials button again. Then I can go to the linker, drag the material to the BG. And now I don't see anything because we need the ramp to read from our UVs. So we can go back to the BG. So there's probably like a native node to do this, but I'm just gonna do this with a primer reader. And the UVs in Solaris or in USD are called ST, don't ask me why. I'm gonna pipe this in here. And then we can do a rotate it by 90 degrees. And now we have something similar to what we had in the Redshift. And I'm also going to go back into my master material. And here we're going to add some bumps. So unfortunately, the Max and Cinema 4D noises are not implemented. So I'm going to use a Fractal 3D, pipe this into a bump map node, similar to how Redshift works. This goes into geometry and then normal. And then now the scale is super high. Right now the frequency is too high, so we can create a position, MaterialX position, pipe it into the position, and then we can multiply this position. And now we have those tiling parameters. So if we up that to 10, you can see that the noise becomes smaller. It's still way too high. Way too high. Something like that maybe. And then we can do another color ramp. Set this to 0.3, and this goes to specular roughness. And then I'm also gonna change my IRR. I think I had 145, and then subsurface, I'm gonna up this to 0.7. I'm gonna drag down the scale to 0.005, I think. And we get something like that. Finally, we'll add our actual render settings that we'll use when writing to disk. So we can drop down a Karma setup, and this gives a pop-up box that I don't know about, so I'm just gonna click OK. And the way it works here is that the resolution gets set in the Karma render settings, but the aspect ratio gets set on the camera. So that's pretty nice. So you can just up this to 1920. So I set it to 1920. And the reason why it looks so weird is because we haven't linked the actual camera. So you can see that the camera path here is wrong. So I'm just going to drag and drop my camera in here. And now we get the right aspect ratio. I'll change the engine settings from CPU to XPU. And then I'm going to go to limits, up DJI to 4 bounces maybe. If you want motion blur, you would go into camera effects, and motion blur is turned on by default, but not velocity motion blur. So I'm going to turn this on, and I'm also going to turn on instance velocity blur just to be safe. So now we should have velocity blur enabled. Let's add some depth of field. So I'll select my camera, and this is how it's supposed to work. So by default, your f-stop will be set to 0, which means that it's deactivated, so no depth of field at all. So if I open this up, maybe set it to something like 2. You can see that we get some blurriness. And then here you get some instructions. If you don't see this, you need to click this gizmo or press enter. So if you hit Shift F, you're supposed to be able to click Shift left click and pick a focus point. This does not seem to work for me at all. All right, this is me from the future. Sorry about this, but I finally figured out why my focus plane was not working. And the reason is because I forgot to add a / somehow in the primitive path. It needs to have a / at the root level. And it seems to work whenever I do this. So now I can pick my focus with shift clicking wherever I want my focus to be at. If I hit Shift F again, we get this filled version so that we get a bit more clear selection of where our focus is. And if I hit Shift F again, we'll go back to normal mode. So Shift F, Shift left click to set the focus. Okay, back to the tutorial. Maybe something like this. One feature that I'm missing in the USD camera that I wish they would implement ASAP is to be able to put a null or an object and automatically measure the focus distance to that object. That would be super useful. There's a way to do this with Vex or Python, but honestly, I think this should be implemented natively. But one thing that you can do is that you can constrain the camera to look at an object. So we can make it look at the BG, for example. We can make it look at the main object. So that option does exist. So that's good to know. If you want to make a camera follow a path, you can do so with the follow path constraint LOP. So we're going to pipe in the camera to the first input, and then in the second input, I'm going to create a circle. Here, I'm going to change this to a polygon, just up the sizing here, switch the orientation. And then in target source, I'm going to change this from first input to second input. And then I can just drag the circle into the target field. And if I toggle the display flag on the follow path constraint LOP, we can see that the camera is now constrained to the path. And then you can animate this with the position here. So you can create like a turntable camera if you switch the axis to X and then just animate it. So what I can do now is I can go to my USD render op, set the frame range, something like that. And then this is pretty important. If you render locally, checking this checkbox can help your render speed quite a lot, because what it does is it'll create a sequence of .usd files before it sends it to actually render. I'm going to toggle monitor here. So if I toggle the mplay monitor, now we'll also get like a preview of a render so that we can see it cooking. If we don't have this clicked, it will just show like a progress bar, so we won't see an actual image progress through. But now when I have this clicked, I can hit render to disk, and it will create this USD sequence first. So once this finish, it will kick off the render, and we should get the mplay window pop up. So yep. So this mimics sort of the behavior of Cinema 4D's picture viewer, for example, when you hit render. But I think the main strength of Karma is just like the look dev tools that you have in Solaris. So you can create snapshots. We haven't gone through that. But you can create snapshots as you progress through your lighting. And you can always revert back to those settings of your lights. I might make like a full look dev tutorial in Solaris as well when I get more comfortable with it. But yeah, thought I should mention that as well if you want to search for more information on your own. I just wanted to give a heads up because you might run into this if you start with Solaris and haven't opened Houdini before. The first thing you might want to do, just in order to like mimic the color response that you would get from like Redshift and Cinema 4D, is to go up to your perspective here and check this correction toolbar. And then here you can enable Open Color IO, and then you can change it from untone map to ACES 1.0. Then you should get like the same sort of color settings that you would expect from Redshift, for example. So to summarize what we've learned today, we started off by importing Houdini created geometry with SOP import LOPs. We we initialized our directory with the primitive LOP, and we now know that the primitive kind sets the role and the primitive type tells it what it is. And those are the two main things that I think you should know about at the very least. We've also seen how we can organize our scene hierarchy with the graft branches LOP, and this gives it a very visual way to see what we're bringing in and at what stage we're doing that. We've also seen how we can create materials with MaterialX and Karma, and then we've been able to link these materials with the material linker, and we've also seen how we can assign it in multiple ways as well. Then we've taken a look at how we can constrain different objects to other objects in the scene graph. We've also taken a look at how we can bring in lights and how we can set up lights. The thing that we didn't have time to take a look at today is that much like the material linker, you can create a light linker. And this will essentially do the same as the material linker, where you just drag in your lights and then you can control things like light contribution per object or per primitive. You also have the light mixer. And this is a pretty powerful tool where you can just drag in your lights. So if I drag in my lights to the mixer, we'll get these slide parameters per light. So this lets you dial in your lights from one single place without having to jump back and forth between different light nodes. In general though, my biggest tip when starting to learn Solaris is to do as much as you can in SOPs and then import it into Solaris like we've done here. Now, I should mention that there is a small performance trade-off when importing elements directly from SOPs. When using the SOP import, we're effectively keeping a live link to our geometry in SOPs. In a massive feature film, you'd usually bake this geometry out to a USD file on your drive and then reference or sublayer it in. But the point being, as a solo designer, what I care about is the speed at which I can take an idea to a final pixel, and keeping it live lets us work faster. Just know that whenever you hit the render in the viewport, Houdini has to cook and translate that SOP geometry into a temporary flattened USD stream. So since it's not reading a file off a disk, it has to hold, or at least I think it doesn't. I'm not sure, please correct me if I'm wrong, but I think it holds this in memory, so in your computer's RAM. So if your scene starts feeling sluggish, that's your sign to bake it out. So just keep that in mind. Another important thing when importing SOPs is that if you have multiple pieces, if I create a SOP crate and then we'll just drop down a box, we'll create a sphere, and we'll create a torus or whatever. So if I merge these pieces of geometry, so now we are on the geometry level, and then if I head back up to the stage context, you can see that in our geometry spreadsheet or our scene graph tree, these gets imported as one single mesh. So in order to make Solaris recognize them as individual objects, you'd need to give each mesh a unique name attribute. So you can either drop down a name attribute here manually, and then you can just give it a name, or you could do as I usually do, I just create a assemble LOP, or assemble SOP, and this will create the name attribute for us. So you can see we have piece 0, piece 1, piece 2. And now if we head back to the stage context, we can see that they do get represented as individual objects. I also want to clarify that in USD, an attribute is any piece of data of an object, like a camera's focal length, for example. We touched on primvars, and primvar is a special type of attribute that our shaders use to look up things like color, UVs, and so on. All primvars are attributes, but primvars are specifically designed to inherit values down the hierarchy in the scene graph. Unlike SOPs, where data flows node to node, multiple LOPs can modify the same prim independently. So what I want you to remember is that in Solaris, the scene hierarchy determines the relationship in your scene, not the node network. And that's all I had time for this time. Hopefully you now have a basic understanding of how to get started with Solaris. There's tons of USD specific topics that I didn't have time to cover in this video, like going through layering and how those layers have different opinions and which opinions are the strongest. But let me know if you'd like to see more Solaris based content on this channel. For now, if you want to learn more in depth what we talked about today, I'd highly recommend giving this video from Pixel Ninjago. I'll leave a link to that in the description of this video. I think that's a good one if you want to learn more about these USD related contents. Thank you so much for watching. I'm Joachim, and I'll see you in the next one. Bye.